start my sharing, presenting in Teams, and then I'll do my intro here. Let's see. Present. Go ahead and give me a thumbs up when you guys can all see my screen here. Oh, it disappeared. One more time. Everyone see that?
It's coming up. There we go.
Perfect. Okay, so quick intro on me. Name is Kevin Kraus. I am an Azure technical specialist within same group as Derek within the Midwest organizational unit within Microsoft, and we support the application innovation space. I am one of the Microsoft or EAP champs within Microsoft for our enterprise app patterns program, and so I have a lot of connections with the developer and engineering groups that are supporting these app patterns, and I've presented this for several other folks, internal and external. And so what we're going to dive into is going to be what are enterprise app patterns, and of course our first pattern, which is going to be the reliable web app pattern. Excuse me. So, and please, if you have questions, go ahead and ask them as we go. We'll have some Q&A at the end, but for the most part, I want to be able to answer questions, be a little more informal than other ones that I've done. Feel free to just kind of interject or raise your hand, and we'll try to get those questions answered as we go. So, so Microsoft has an engineering group known as Microsoft Engineering Division, which is also known as DevDiv internally. And they recently introduced their new, it's a highly anticipated initiative called the Enterprise App Patterns, EAPs. And these patterns provide prescriptive guidance and reference implementations that enable enterprise developers and solution architects to modernize those mission critical workloads on Azure, in a reliable, secure, high performant, cost-effective manner with modern design and operational practices. EAPs were really kind of there to address key feedback we continue to hear from enterprise customers and the field sellers within Microsoft, that they need really a better end-to-end application architecture guidance in order to be able to reduce that time to proof of concept, accelerate customer journeys to modernize their app estates into Azure itself. And so these EAPs, they include packaged, reliable starting points, or reusable starting points, with guidance, reference implementations themselves. They have deployable stacks, automation with multiple environment configurations, along with simulations themselves. And so we're going to talk about those simulations as well for those proof of concepts and for those demonstrations. Or you can just use the enterprise app patterns to be able to learn complex concepts. Design patterns, best practices for enterprise applications, really to address things like high availability and reliable services, caching, managed secrets, identity, those types of things. So let's go kind of deep dive into this. Let's talk about, really that journey, the vision that our DevDiv group really was looking to do here. And this one's going to be specific to the reliable web app pattern. We're going to have a lot of other patterns that are coming in the future as well. But really the goal of this reliable web app pattern was to take a phased approach, helping customers migrate on-premise line of business applications to the cloud. Doing that as quickly as possible and to take advantage of cloud-based features and services for high availability, security best practices, and then monitoring those types of things. So as you can see here, we're in phase one here, and they are really designed to align to what we have out of Microsoft called the Microsoft or the Azure Well-Architected Framework. They are designed to target multiple development stacks, take advantage of modern tooling, modern processes, as well as to be able to accelerate field members, people out there, customers themselves, to be able to deliver those proof of concepts and really help jumpstart and accelerate the customer's journey out to the cloud. And so our BA, again, is that first phase And we have future phases as well. You can see the modernize in the cloud and the scale out in the cloud. And those are future patterns that we will support over the overall journey from getting on-prem out to having a cloud native scalable cloud solution. All right. I wanted to talk a little bit about the little stack on the bottom there. Again, I mentioned we are building it off of the well-architected framework, so we'll talk a little bit more about those pillars. We have a .NET and a Java stack or Java version. Both of those, let's just say one of them is running off of Bicep, the other one uses Terraform. And of course, we have support for CI/CD pipelines from GitHub as well as Azure DevOps. It's all built on top of application insights, so we have observability. And then again, we talked about those simulations. Those simulations are just kind of demonstrate why it is a reliable web app. All right, so let's talk about what our principles were when we started this whole thing. We really wanted to kind of dive into these principles. I showed you the principles that are kind of aligning to some of the different stacks I just showed you. One extra here is really about cost profiles. How do we make it so that we can stand this up in maybe a dev environment where we have more cost-effective resources versus what is a full performant production environment itself. And the features we were really targeting were the ones that you can see here. So we wanted to be able to make sure this was a multi-regional, highly performant application that had patterns like cache aside, retry, circuit breaker. And we wanted to make sure it was also up to speed when it came to security. So we have our firewalls, private endpoints for access to our dependencies, et cetera. And of course, we did this all around targeting a service level objective. So we would make sure that it matches what our customers would need in that realm. So let's dive into these pillars of the well-architected framework and how this particular pattern applies to these different pillars. So first, let's talk about reliability. You're going to see when I show you these architecture diagrams here of exactly how it was built. These are really going to be bullet points that you'll see when you see that diagram of how we built out that architecture. So from a reliability standpoint, we added infrastructure and code design patterns to ensure that we had resiliency, handling this failures gracefully. Patterns such as retry, circuit breaker are implemented within reference architecture, and I will show you inside of the code where we implemented those particular patterns. On the security pillar, we use modern authentication and managed identities for all that inter-service communication. We have dependencies like Redis, Key Vault, SQL, and all of those dependencies are only accessible through private endpoints within the VNet. On the cost optimization side, we are using Bicep and Terraform. Bicep is for our .NET, Terraform is for our Java one, although you could use either or. Those templates are there to provision both development and production workloads using parameterization for that right-sized intended environment that you're looking to deploy to. We also use a cool tool called the Azure Developer CLI, also known as AZD, which enables developers to quickly provision and tear down environments that save costs. And it's really developer friendly as opposed to the AZ CLI, which is specific to more of that infrastructure or operational side. Operational excellence wise, we have that AZD CLI or that Azure Developer CLI also provides out of the box support for GitHub Actions and Azure DevOps pipelines for quickly creating, enabling pipelines around CI/CD for setup and execution. Also, because we have defined the environment using infrastructure as code, we enable repeatability and consistency through automation. That helps with our operational excellence. We also address observability through the use of Azure Monitor and application insights. And the last pillar here, from a performance efficiency standpoint, right, all of these are built in an on-demand scalable kind of environment in Azure, utilizing appropriate compute size tiers, as well as service-specific scale rules to meet the application capacity needs depending on that environment. Quick business contact on the reference architecture that is included within this .NET pattern. So the application for the reference architecture and the reference implementation is a business called Relic Cloud Concerts. It is a fictional company, of course. It is a large monolithic application that is currently being used by the internal call agents. And of course, what we're looking to do is when we move this out to the cloud using this pattern, we're doing this because they're currently seeing increased sales demand, and we're looking to achieve these following goals, as you can see here on the slide. So that just know that when you start to use this application, all of our scenarios and simulations will be based off of this business context. So what does it look like? So this is the current 1.0 version. There is a 1.1 version that is currently being built and is not yet released to GA. It is going to be utilizing the hub and spoke networking model for access to the different resources. So right now I'm going to only go over the 1.0, but I can show you where you can take a look at the new one coming out. And it honestly is going to be released probably the next month or so. But if we look at this, first thing you'll notice is that this is a production-based architecture. This one is a multi-regional deployment. You can see that we have Azure Active Directory, which this needs to be updated to Microsoft Entra, going into a front door with a firewall, and then, of course, being distributed to one of the different regions. From there, it has our Azure front end implemented in the app service compute domain, with an API backend also running in Azure App Service. They are all within a specific VNet with endpoints that connect directly out to their desired resources, such as Redis Cache for caching, for our database, which is our persistent store, and of course being able to access our Key Vault and our app config service as well for centralized configuration. So, and this, is a typical scenario of a monolithic line of business .NET application that you would see at a customer's website or at their customer's environment. And so really in support of migrating to the cloud, the team really focused on reliability, and they added that necessary Azure services to meet the defined SLO requirements that you'll find in the guidance that we provide. We're also including security best practices like managed identity and Key Vault for secret storage and management, as well as reliability best practices, as in the scenarios that we talked about, which is retry and circuit breakers. It also has, well, we already covered that stuff. So let's move on to the next one. I really kind of wanted to touch on where you can go to be able to access these resources. There is a GitHub repository. I think you should be able to click on that link to get to where it is. It lives in our Azure organization out in GitHub, but you'll be able to see all of the resources that are provided, as well as that guidance that will tell you how to implement, deploy, and run those simulations. If you're curious about the Java side, we have a Java reference architecture here. The main changes here are things such as using PostgreSQL, and the reference architecture uses some media files, so we're using Azure Files as well for that. But it's the same concepts. As far as the repository for the Java side, here's a link to that, along with our same reliability, guidance itself. Just to quickly, we'll talk about these in more detail, but these are the three patterns that are being used for our simulations, and you can demonstrate these patterns using the guidance within GitHub. So you can turn on some configuration to have certain failures every other call to an API to show how our policies are actually being executed, as well as being able to turn on the cache aside pattern to store user information within our Redis cache dependency. So let's dive into the demo. I'm going to share out my desktop. And let's go take a look here. First, so and I can't, I'm going to be looking at this on my main screen, and I'm looking at you, so I can't see if any hands are up. So please kind of just pipe in if you can, since I can't see any of the activity. But I'd love to be able to answer questions if you have them while we're doing this.
I'm keeping an eye out too. If somebody raises their hands or post a question in the chat window, I'll let you know.
Thank you, Derek. So here is where we've posted our customer-facing guidance out on our Azure Architecture Center site here. You can see both of our different versions for our .NET and our Java, but this is a great starting point for everyone to be able to learn about the patterns themselves, and of course dive into each of the individual patterns, and then be able to then use some of the links to get some of the more deep information about how we made our decisions on this pattern itself. If you find the one that points to you, the GitHub repository, it will point you to here, which is in our Azure organization. And then you'll be able to see all of the different guidance that we provide for this particular pattern. We'll give some information around the workflow about what we're trying to accomplish and how the actual architecture works. We will, of course, have some prerequisites that you'll need to be able to deploy this out to your Azure subscription, but we do support dev containers. So you can, if you have Docker Desktop or Rancher, you should be able to stand up our dev container environment, which has all of these dependencies or these prerequisites already installed and configured, and should be able to run it that way. Once you have that, of course, go out and clone things. And this is where we're going to start using our Azure Developer CLI to be able to initialize environments. And then we'll have a handful of setting of environment variables to be able to drive our infrastructure as code, in this case, bicep templates. And then what we'll do here is run the AZD provision. This takes on my computer roughly about 25 minutes to be able to deploy. The longest resource for deployment is going to be our Redis cache that currently takes roughly about 20 to 25 minutes to deploy. Once you have that done, you will need to be able to create what our app registrations to be able to register the API as well as the front end with the environment. And when you do that, of course, we'll need to also take some of the configuration and store that into our configuration store as well as our key vault. That script will help manage that. Once that's all done, the entire Azure resource group should be provisioned and ready to go, but no application has yet been deployed. So the reference architecture, as we mentioned, was a Relic Cloud Concerts application for call center agents. By just going to here and saying what resource group we want to deploy to and doing AZD deploy, using AZD's format for its templates, it'll automatically compile, build, publish, and package and deploy out to our environment. When that's all done, of course, the nice thing about that, if you're using environments such as dev environments and you don't want to have that burning on your subscription, you can AZD down and automatically clean up your resources if you need, and then stand it back up again whenever necessary. We also have support for local development. So if you want to be able to store your secrets as well as be able to connect and do some debugging, we have guidance around that as well. And then we have some other things, and I'll come to it here. We do have a page that is for how to kind of simulate the design patterns that we've implemented here. So we have guidance on how you can show we are going to execute on our retry pattern, our circuit breaker pattern, as well as our cache aside pattern. So what do those look like? Let's go take a look at those patterns real quick, and then we'll dive over into the Azure side. So this is Visual Studio Code, and this is my output or my resources from the GitHub repository. They are configured in a very specific way to support Azure's developer CLI. There has to be an infra folder that contains your templates, whether that be Bicep or Terraform. And you have to have a source directory, which is going to have all of the different reference architecture application or your own application if you decide to plug it in there. From there, we have our support, as we talked about before, for our GitHub Actions pipelines, as well as our Azure DevOps pipelines. We have support for dev containers, so we do have a definition of a Docker file that contains an image that has all the prerequisites necessary to run. And of course, we have a handful of other assets that are used for just the guidance that we use. So let's go take a look at the patterns quickly, and then we'll dive into what was deployed and how it all works. So we want to go dive into the API itself. So we do have a service in here for being able to simulate a failure on the API side. And it's right here. So we implemented this as a piece of middleware that when it reads the configuration values that you set up on your app service, it'll automatically every other, depending on how you set it up, it will automatically fail. If you set it up to fail all the time, then of course we will then spring into the circuit breaker pattern where it will say we're going to turn things off for a little bit, cool down, and then try again in some configured time period. So that's happening at the API level. If we dive over into the web level, let's go in to see how we assign and manage these policies against our services. We have many different services. These services, we have private methods here that are for managing the registration and configuration of these services. We have a handful of services for purchasing tickets, for searching for concerts, and we have implemented these as poly policy handlers. So Poly is a .NET is a library for managing policies that will support these particular patterns. And as you can see, we have currently one policy per service. Of course, you could have different ones per different services. And right now, we will automatically turn on retry and circuit breaker for each one of these different services, and the APIs themselves will automatically be managed by these policies. Any questions on the patterns themselves? Okay, let's keep moving on. So what got deployed after 25 minutes if I were to go through the process and the guidance that I just showed you? Oops, open please. Here is a resource group for an application that was deployed. This one happens to be 1.1. I did not have time to deploy the 1.0, so I do apologize. There are some things that will be different, but there's some things that will be the same, which I'm going to cover here during this call. So the big things, of course, are understanding when we look at that reference architecture. Well, I'll dive back to that reference architecture so we can see it. So here, for this reference architecture, we're going to dive in. We're going to see our two different app services. We're going to see our application insights. We're going to see our centralized app configuration, et cetera. Let's just dive in to take a look at that. So I have this ordered by type, so we can see now we have our centralized configuration. We have our front end and our API service all running in our service plan. We have our front door for our access to our region itself. We have our application insights, which is backing this from a monitoring and observability standpoint. And then we dive in here, of course, we have our managed identities and our SQL Server backend stuff for storage. So what does it really look like? And then we'll look at application insights. We've already run a handful of transactions through here. So you can see that we do have a simple application front end calling an API backend and using these individual services through our private endpoint configurations. So what does that really look like? Well, this is the reference architecture itself. It is an application that is backed by Azure Active Directory or Microsoft Entra. And so when you use this, you have to log in with whatever tenant this is configured with. In this case, it's configured with my Microsoft tenant. And we will be able to then view our and search our upcoming concerts. If we decide that, and again, this is for an agent, so when the agent's on the phone call, they're searching for the person that's on the phone. If they want to go see Jennifer Wilkins, we can see how many tickets they want. We'll add 10. We'll say confirm. We can add more, but let's check out. We'll add in information. This is all just stubbed out for purchase. And when that happens, of course, we will see individual tickets. I pick 10, so you'll see a whole bunch of them. And these are the barcodes that are stored in our blob storage for use that we can then send these to our customer, and the customer can use those to be scanned into the event when they want. So that is the way this architecture works. If we wanted to configure this for simulations, we can do that by going back to our simulations. Let's take a look at the retry pattern. We have a specific configuration value called the retry demo, and we can set that value to 2. So that means every other call will fail. And when that happens, you should see 0 issues with the site, because what will happen, it will try to do a retry and the second call will succeed. And all you'll see is maybe the smallest amount of latency, depending on how it's configured. When it comes to the circuit breaker pattern, we also have, we'll use that retry demo, and we will set it to 1, which should be failing every single time. And when that happens, we will try, I think the policy, the poly policy is set up to fail after 5 times, maybe it's 3 times, I can't remember. And when it has those failures, it'll turn on the circuit breaker, wait for 30 seconds, and then try again. The behavior of the front end will be, we currently don't have access to this, and our apologies. So, but that's great to allow our API then, of course, to recover, hopefully get into a healthy state, and then we can call back when it does recover correctly. Cache aside pattern is also something that just is turned on by default. If you want to demonstrate the cache aside policy, what you can do is you can go into your Redis cache console and run some commands to be able to output what is being cached. And as you'll see from this dump right here, and this is not a great screenshot, but this is basically the user profile that is logged for the user itself that is logging in, which is in this case would be the call center agent. And then that call center agent, and then of course that way that they're not calling out to the identity store for this information each time. All right. With that being said, we are at the half mark. This is exactly where I wanted to be. So what I'd like to do is be able to kind of take some questions. If you guys have any thoughts or ideas or want to know more about the pattern, let's hear from it. What do you guys have?
Feel free to come off chat or ask in the chat window if you want, or come off mic.
Let me ask this question. How many of you folks have applications that are on-prem, front end, potentially APIs with them, SQL back end, so your basic kind of, monolithic application? How many of you have those that are still sitting on-prem?
Raise your
Everyone's
hand.
okay, well, we got Rob's got a thumbs up. So, the goal here really was that, I run into customers all the time that are moving to the cloud and having a cloud journey moving, and they always say, well, we have these ones over here, these apps that are on-prem that are just old. They're ones that we just don't want to touch right now, and it's too difficult. This pattern is made for them. All depending, of course, on what technologies they're using, what versions of those technologies they're using, right? There's still going to be some sort of prep, some sort of work that needs to be done, unless they're, running on things that can come straight over and translate into app service directly. For the most part, this pattern will apply. It definitely applies from the provisioning standpoint, where we're going to be setting up an isolated VNet, being able to use those security practices around managed identity, and of course the ability to keep that secure and of course scaled to the way they want it based on Azure scalability advantages. So also, we have it in GitHub. We are actively responding to issues and requests and feedback. So we would love to hear feedback if this is something that you want to use just to learn what it means to set up an Azure secure configuration based on our well-architected framework. You can use it that way, and then of course change it to whatever needs you need. We have most customers that find the Bicep and Terraform templates are probably the most useful out of these patterns, of course, so please use those, but we just want to be able to hear from you if it's working or not. And then, of course, eventually when we get the next pattern is going to be where this application has already been moved out into Azure or into the cloud, and you will then, of course, figure out how to then move it from a monolith into more of a distributed application. Derek, you had your hand up for a second.
Bad click. I was trying to get to the chat window instead. So
All right.
I had a quick question.
Yes.
So as far as like, it sounds like you've dealt with both Bicep and Terraform. I've mostly only lived in Terraform land. Is there anything you've noticed, like which, like one better than the other, or one that has particular gotchas that the other one doesn't?
Well, for the multi-cloud, right? Bicep is just for Azure, right? It is a layer on top of our resource management system. So obviously, if you're moving your applications to the Azure cloud, I think that Bicep has the advantage because we have new features coming to our resource management system on a faster cadence that can be translated into support on the Terraform side. We've already seen that with regard to certain customers who are using Terraform, where we see support for certain features within Azure in Bicep and within our ARM system, but not yet moved into the current versions of Terraform. So that's one thing as far as, but I think that is really going to come back to what kind of skills do you have at your organization. If you currently have Terraform skills, then absolutely use Terraform to deploy to Azure. And then, of course, if you decide that you're going from scratch, I highly recommend, if you're moving to the Azure space, to really look at it, the Bicep first.
The one thing I always like too about Bicep is there's no state file. So Terraform, you have to maintain that state file somewhere out on storage. If that state file gets wiped out or lost, then it tends to cause some problems. Where with Bicep and ARM, Azure is your state file. So it's looking directly at your subscription you're deploying to, looking at what resources are there, and comparing and differencing at that point. So you never have to worry about that state file. But like Kevin said, it's Azure specific, so it's a domain specific language that was created for Azure. Where if you're a multi-cloud environment, then things like Terraform definitely make more sense.
Yeah. I was going to do this too. More questions, please, if you have them. But I'm going to share again, because what I want to do is I wanted to jump to back to the repository and dive into our 1.1 branch, just so you can kind of see where we're at with this. This is currently going to be eventually moved into our main branch, but right now this is our hub and spoke model resource guidance, excuse me. And so we highly recommend, we have a lot of feedback from our customers saying we use the hub and spoke model. We have access to Bastion servers from this particular VNet, and we want to be able to then allow people internally then to access these resources from a security perspective. And so we have this guidance coming out soon. But if you want to be able to look at it now, please jump over to the RWA version 1.1 branch to take a look at the newest work we're doing, which should be released within the next, I'd say, month and a half. And I work closely with Ken and the other team members. So if you guys see something and you want to be able to connect to me directly, some sort of feedback that you just rather not go through the issues section of our GitHub repository, and hit me up directly. If it's something that is really impactful, we will certainly get on calls with customers to talk about how to improve this.
So Kevin, you also talked about you were part of the EAP group within Microsoft. What other patterns are they looking at, or have they published besides the reliable web app?
So we kind of paused on the second pattern coming out, which is called the modern web app pattern. Ken is building the modern one for .NET. We have a gentleman named Nick who's developing the Java one. And the Java one had to pivot on its own because we were using an open source application called Prosware that has media files, and we just had certain things that didn't kind of line up to the patterns we wanted. It was the wrong architecture to choose. So we moved on, and he started rebuilding a whole new one using our wonderful fictional Contoso name brand, and it's called Contoso Fiber. So that one's coming out as well within the next month or so. But when it comes to the second pattern, modern web app pattern, Ken had to go back to the get the 1.1 going. Once that's done, I think he'll be very, very quick on getting out the modern one. We also have other patterns looking around, integration patterns and some other ones using containers. So we're currently doing that. The group is small, so we're trying to build that group up right now. It's a brand new initiative. So look for things happening up in the next, half a year to a year. And that's it, everyone. If there's no more questions, I appreciate your all time and having me on the call.
Last opportunity for questions for anybody. In other words, if there's something you think about after the fact, by all means, feel free to reach out to me, and whether I can answer it or I'll reach out to Kevin or anybody else I need to get your questions answered.
Thank you, everyone.
Take care, everyone.